You probably feel confident that you understand time. You check your phone to see the hour. You notice birthdays arriving faster than they used to. You remember what happened earlier today and make plans for tomorrow. Because these experiences are so familiar, time feels simple, almost self-evident. But that sense of familiarity is misleading. What you experience is not time itself. It is your brain's way of organizing change, memory, and expectation. It is a biological strategy, not a fundamental truth about the universe. Many people imagine time as something that flows, like a stream carrying everything forward. Past behind you, future ahead, present rushing past. It is a comforting picture, but when you examine it closely, it falls apart. If time is flowing, what exactly is its speed? 1 second per second. That statement doesn't explain anything. It's like saying a meter stick is 1 meter long. True, but meaningless. It adds no insight into how reality actually works. When physics examines time, it removes poetry and keeps precision. Time does not push events forward. It does not move on its own. Nothing is being carried. The sense of motion comes from how our minds interpret sequences of change. To understand this properly, we need to begin not with the universe, but with the human brain, because that is where the confusion begins. You might believe you possess an internal clock that reliably tracks duration. In reality, what you have is a collection of mental techniques. Try a simple exercise, count 60 seconds without using any external reference. Some people do this by silently speaking numbers in their minds. They internally pronounce 1, 2, 3. If they are interrupted, asked a question, forced to speak aloud, the counting collapses. The system breaks. Other people use a completely different method. Instead of hearing numbers, they visualize movement. They might picture marks sliding past or a sequence of images advancing at a steady pace. These individuals can often perform other tasks at the same time, reading text, folding clothes, without losing track of their count. 2 people, same task, entirely different internal machinery. This difference reveals something important. The feeling of time passing is not universal. It is not built into reality. It is a mental construction assembled from whatever cognitive tools your brain prefers. When physics tries to describe time, it cannot rely on those sensations. It has to ignore how time feels and focus on what can be measured. In physics, time is not defined by experience. It is defined operationally. That means we don't ask what time is in some philosophical sense. We ask how we identify it and compare it. From this perspective, time is simply a method of ordering events. One thing happens before another. That's all. Imagine laying photographs on a table. One shows a sunrise, another shows noon, another shows sunset. Nothing is moving on the table, yet the order is meaningful. The sequence exists even without motion. Time works the same way. Events are arranged relative to each other. The arrangement is what matters, not any imagined flow. A common mistake is to treat time as a container, something that exists independently, ticking away even if nothing happens. This idea comes from older views of physics, where time was assumed to be a universal background. But that picture does not survive modern understanding. Time has no meaning without change. If nothing changes, no motion, no vibration, no interaction, there is no way to define a second or an hour. Without processes, time is undefined. Every clock depends on physical behavior, a swinging pendulum, an oscillating crystal, atomic transitions. Time is not separate from matter and energy. It is inseparable from them. Remove all physical activity, and the concept of time disappears with it. This often clashes with intuition. It feels natural to say that time causes things to age or decay. But that language is misleading. Time does not act. It does not cause. Milk spoils because of chemical reactions and microbial growth. Bodies age due to biological processes and entropy. Time is the scale we use to describe how fast these processes occur. It is not the driver. It is the measuring tool. Think of it like distance. Distance doesn't move objects from one place to another. Motion does. Distance only tells us how far the motion went. In the same way, time doesn't make things happen. It records how change unfolds. This idea becomes even stranger when we discover that our measuring tool, time itself, is not rigid. For a long time, it was assumed that all clocks ticked at the same rate everywhere. A second on Earth was thought to be identical to a second anywhere else. This turns out to be false. The rate at which time passes depends on motion and gravity. This is not a flaw in clocks. It is a property of reality. To build intuition, imagine movement as something that must be divided. Suppose you are traveling across a map. If you go entirely north, all your motion is devoted to that direction. But if you turn northeast, some of your motion goes north and some east. You cannot maximize both at once. In the structure of the universe, motion is shared between space and time. Every object moves through spacetime at a constant overall rate. If you are standing still relative to your surroundings, all of that motion is directed through time. If you begin to move through space, some of that motion is diverted. As a result, less remains for time. Your clock ticks more slowly. This is not a metaphor. It is measurable. Fast, moving clocks genuinely record less time. Objects traveling near the speed of light age more slowly than those at rest. At everyday speeds, the effect is tiny, but not zero. Modern technology must account for it. Navigation satellites, for example, experience time differently than clocks on Earth. Their systems require constant correction. Without it, location errors would accumulate rapidly. At the extreme limit, something remarkable happens. Light travels at the maximum possible speed. For light itself, no time passes between emission and absorption. From its own perspective, if such a perspective could be defined, there is no duration at all. The universe collapses into a single instant. Beyond speed, there is another reason time feels directional. We remember the past, but not the future. We see things break, but never spontaneously reassemble. This asymmetry does not come from the laws of motion themselves. Most fundamental equations work equally well forward and backward. The source of the arrow lies elsewhere. It comes from probability. Ordered states are rare. Disordered states are abundant. There are countless ways for an object to be damaged and very few ways for it to be intact. As systems evolve, they naturally drift toward configurations with more possible arrangements. This tendency is called entropy. When you watch events unfold, you are watching entropy increase. That increase is what gives time its apparent direction. Memory itself depends on it. Recording information requires physical change. If disorder did not increase, memory could not form. In a perfectly uniform universe with no gradients or structure, there would be no meaningful distinction between before and after. This means your sense of time passing is deeply connected to how your brain detects change and loss of order. You are not sensing time directly. You are sensing entropy. Now return to the people counting seconds in their heads. Both are imposing structure on something that is fundamentally flexible. The mind evolved to track intervals for survival, not to grasp space-time as a dimension. Our intuition is efficient, not precise. It prioritizes usefulness over accuracy. This becomes clear when we examine the idea of now. In everyday life, the present feels shared and universal. But in physics, there is no single global present. Different observers, moving differently, slice the universe into past, present, and future in different ways. Events that are simultaneous for one observer may not be simultaneous for another. There is no universal moment that spans the cosmos. Instead, The universe is better described as a four-dimensional structure containing all events. How you divide it into moments depends on your state of motion. This is difficult to accept because it conflicts with how our minds naturally operate. We are trying to translate a deep geometric reality into a biological interface designed for survival on one planet. Yet, when we stop forcing reality to match intuition and instead adjust our intuition to match measurement, the confusion fades. The equations become consistent. The paradoxes dissolve. Even then, one question remains: if time measures change, what happens at the very beginning? If the universe expanded from an extremely hot, dense state, what came before that expansion? This question tests our definitions. If time itself emerged with the universe, asking what happened before may be meaningless. Just as there is no location north of the North Pole, there may be no time earlier than the origin of cosmic expansion. This idea feels uncomfortable because our minds demand a sequence. We want a story with a beginning before the beginning. But the universe is not obligated to satisfy narrative instincts. Our internal counters may insist on continuing to count even when the tape itself has an endpoint. Understanding time, then, is not just a scientific challenge. It is a psychological one. We are finite systems trying to comprehend structures that do not bend to instinct. Each advance in physics requires abandoning comfortable images and replacing them with more abstract but more accurate ones. The reward is perspective. Even though time is flexible, relative, and deeply linked to motion and disorder, it still works well enough for daily life. You can keep appointments. You can cook meals. The strange behavior of spacetime remains hidden beneath ordinary experience. But knowing it exists changes how you see the world. It reminds you that common sense is not a guide to fundamental truth. It is merely a survival tool shaped by evolution. Learning physics is not about memorizing facts. It is about learning when to distrust intuition and how to replace it with clearer ways of seeing. Time, once stripped of myth, becomes something even more interesting than a flowing river. It becomes a structure woven into the universe itself, quiet, flexible, and far stranger than it first appears. Up to this point, we've stripped time of its familiar disguises. We've let go of the flowing river, the ticking background clock, and even the comforting idea of a shared present. What remains is something quieter and more unsettling. Time as a dimension tied to change, motion, and probability. But once we accept this picture, a deeper question naturally emerges. What role do we play inside this structure? Because so far, time sounds cold and impersonal. It bends with speed. It dissolves near the origin of the universe. It ignores human intuition. And yet, somehow, conscious experience exists inside it. You are here, aware, remembering, anticipating. That alone tells us that time is not just a physical parameter. It is also something filtered, interpreted, and reconstructed by the mind. Memory is the key. Your brain does not store the past like a video archive. It reconstructs it. Every memory you recall is rebuilt using fragments, patterns, and emotional weight. This reconstruction happens now. The past does not exist anywhere you can access directly. What you call the past is a present time model assembled from physical traces, neural connections shaped by entropy. This means memory itself obeys the arrow of time. You remember low entropy states evolving into higher entropy ones because memory formation requires energy dissipation. A brain that remembers must consume fuel and generate heat. Memory is not a passive record. It is an irreversible physical process. That is why the future cannot be remembered. Not because it is forbidden by logic, but because it has not yet left physical traces. There is nothing to reconstruct, no imprint, no gradient. The future lacks the thermodynamic structure that memory requires. In this sense, consciousness does not float through time. It is carried by irreversible processes embedded within it. Now consider how this changes the idea of choice. If the universe is a four-dimensional structure where all events exist as part of spacetime, it is tempting to imagine that everything is already there, laid out like frames of a film. This raises an uncomfortable question. If the structure exists, is the future already fixed? Physics does not give a simple yes or no. At the level of classical mechanics, systems appear deterministic. Given perfect knowledge, outcomes seem inevitable. But at the quantum level, probability enters in a fundamental way. Not as ignorance, but as an intrinsic feature of reality. Certain events do not have definite outcomes until interactions occur. The universe does not merely hide the answer. It does not contain one in advance. This means the future is not a frozen script waiting to be played. It is a space of possibilities constrained by physical law, shaped by interaction, and narrowed by entropy. Your actions matter not because they defy physics, but because they are part of how the universe explores those possibilities. From inside the system, choice feels real because it is real, physically instantiated through branching outcomes, information flow, and irreversible change. This brings us to a subtle but crucial distinction. Physics does not say that time flows. But it also does not say that experience is an illusion. Experience is real. It is just not fundamental. It is emergent, just as temperature emerges from molecular motion and solidity emerges from electromagnetic forces. The sensation of temporal passage emerges from complex systems processing information in a universe where entropy increases. You feel time because you are a system that compares states. You notice differences. You detect change. Remove comparison, and the sensation vanishes. This is why deep sleep, anesthesia, or unconsciousness compress time. The clock continues. The universe evolves, but without active comparison. Duration collapses into nothing. From your perspective, hours disappear instantly. Not because time stopped, but because the mechanism that registers it was offline. Now zoom out again, far beyond brains and memories. As the universe expands, energy spreads out. Structures form, burn fuel, and decay. Stars shine by turning concentrated energy into radiation. Life emerges by temporarily resisting entropy through metabolism. But resistance is local and temporary. In the long run, the trend dominates. Far in the future, stars will exhaust their fuel. Galaxies will fade. Matter itself may decay. Eventually, the universe may approach a state where no significant gradients remain. No hot and cold, no structure and emptiness. Just near uniformity. In such a universe, time would still exist mathematically, but nothing meaningful would happen in it. No clocks would tick, because no processes would distinguish one moment from another. Time would be there, but silent. And without change, the concept of later would lose its relevance. This reveals something profound. Time is not valuable because it passes. It is valuable because things happen within it. Meaning arises not from duration, but from difference. This reframes how we think about moments. The present is not a razor, thin slice dividing past and future. It is a working window, a region where information is actively processed, where entropy increases locally, where decisions are made and records are formed. The no is not a universal instant. It is an operational zone. Your now is defined by how fast signals reach you, how quickly your brain integrates information, and how your body interacts with its surroundings. Change those conditions, and your experience of now changes too. Seen this way, time is less like a line and more like a landscape, one where paths are traced by physical processes and awareness rides along certain routes. So where does this leave us? We began with the illusion of a flowing river and ended with a universe where time does not move, yet everything changes. We let go of intuition and replaced it with measurement. We traded comfort for clarity, and in doing so, we didn't lose meaning. We refined it. Time does not carry you forward. You participate in change. You are not a passenger. You are part of the structure. Your memories, choices, and actions are physical events embedded in spacetime, contributing to how the universe unfolds. Understanding time does not make life colder or smaller. It makes it more precise, and in a strange way, more fragile and more precious. Because once you realize that moments are not replenished by a flowing stream, you stop waiting for time to give you meaning. You start creating it.